Now we are going to discuss a very important concept. When we are going to do sums further, when we do sums, when we do proofs, when we do theorems further, we're going to come across certain situations. When I say certain, I'm going to be very precise, saying 3 situations where we'll have a concept called as triangles having equal heights, right? The 2 or more triangles will have equal heights. Now, what do you mean by this? So we need to learn this concept of equal heights. So what is this, triangles with equal heights? Let's understand. Very simple. I said 3 conditions, 3 cases, so I'm going to teach you the first one. Rather, you learn the first one on your own. We have a triangle ABC, we have another triangle PQR. So in this triangle ABC, if I say base is BC, I consider the height as AD, right? And here I'm considering QR as the base and PS as the height. Here I'm saying that AD is given to us as 5 and PS is given to us as 5. So what do we observe? We observe that the heights are equal. So this is a case where the heights are given equal. We need not think anything apart from that. It is directly given in the sum that the heights are equal. This is one case. It's the easiest thing because we just observe and we come to know. Now the second and the third is very important. Let's understand that. So according to this, if I say heights are equal, then I can say that area of triangle ABC upon area of triangle PQR will be equal to base upon base, that is BC, that's the base, upon QR, that's the base. So we write it as answer as BC upon QR. Very simple. This is one case, right? Heights are given equal. So let's see the next case. Now this is very important, very critical. Observe very carefully. I want you to think and answer the question. I give you a line here, right? And I'm giving you one more line. If you see these 2 lines, line L and line M, will they ever intersect each other? No. And they are in the same plane. That means one thing we are saying that both the lines are parallel. So we have a situation where we have 2 parallel lines. Going to give you a triangle. Observe that triangle. Now triangle ABC. I'm saying that this triangle ABC lies between the 2 parallel lines L and M. Now when I say lie between the parallel lines, what do I mean by that? Understand that. I mean to say that one vertex is lying on one line and the other 2 vertices are lying on the other line. That is what I mean to say. That means if you can see here, A is lying on one line and the other 2 vertices B and C are lying on the other line. This has to happen. Then we can say yes, this triangle is lying between the 2 parallel lines L and M, right? So it is not just that I draw a triangle here and I say that it is between the 2 parallel lines, right? Now observe, I give you another triangle PQR. Now my question is this triangle also lying between the same 2 parallel lines? Think. Yes, because we have a vertex P on one line and the other 2 vertices on the other line. That means right now I've given you 2 triangles. One is triangle ABC, the other one is triangle PQR. Both are lying between the same 2 parallel lines. So observe what happens. In this case, I consider the side BC, which is lying on one of the parallel lines, as a base. So the height would be from A, that is AD. Same way here, QR would be the base and PS would be the height. Now my question to you is, what can you say about AD and PS? Think. What can you say about the length of AD and the length of PS? Think and answer. Think. Yes, what you're thinking is very correct and your answering is very correct. You're saying that yes, AD is equal to PS. You know why? Because the perpendicular distance between the 2 parallel lines, same 2 parallel lines, is always the same. That means if AD is 5, then PS has to be 5. If AD is 10, then PS has to be 10. That means what we are saying that we observe that these 2 triangles, they have equal heights. Why? Because they are lying between the same 2 parallel lines. Now that's the thing which we need to remember. Always remember, when 2 triangles lie between the same 2 parallel lines, their heights will be equal. They will not give you, we have to directly write that their heights are equal. But there is a reason. How do we present that? That is very important. So which are the 2 parallel lines? L and M. So we write there, line L parallel to line M, right? Then we write the names of the 2 triangles, triangle ABC and triangle PQR lie between the same 2 parallel lines. The word same is very important because it is between the same 2 parallel lines L and M. And therefore, their heights are equal. That's the way we present it. Now tell me if the heights are equal. And if I ask you a question, what is area of triangle ABC upon area of triangle PQR? You will say it's so simple because heights are equal. Then area upon area is equal to base upon base. So we'll write area of triangle ABC upon area of triangle PQR is equal to base, that is BC, upon the corresponding base here, that is QR. We get the answer as BC upon QR. So was in the second case. Interesting, very easy, right? Between the same two parallel lines. Now coming on the third, the most critical one, the very, very, very important one. Observe this. I'm giving you right now as we have a triangle ABC, right? I'm taking another point here, fourth point D, and which is on line BC, right? That means I'm saying B, D, and C are collinear. So right now actually you can see 4 points, right? 3 are collinear and the fourth one A is outside, right? It is not on this. So out of 4 points, 3 are collinear. That is what I've given you right now. Okay, let's see what happens. I'm joining A and D. Tell me right now in the figure, how many triangles can you see? 2? No, 3. Yes, there are 3 triangles, right? Which are those triangles? Let's see. One is triangle ABD. The other one is triangle ADC. And the third one is a bigger triangle, that is triangle ABC. So there are 3 triangles which you observe. Now for each of these triangles, we'll think about the base and the height. Now observe very carefully. We'll say there's no height right now. So let's draw a perpendicular. I'm going to drop a perpendicular from A, right, on BC. So that height is A. Now observe for each of the triangle, you're going to tell me the base and the height. Remember, you know the base and the height now. For triangle ABD, just focus on triangle ABD. What's the base and what's the height? Yes, since the height is AE, we know the base is BD. So we write base is BD and height is AE. We wrote that. Beautiful. For the next triangle, observe the next triangle ADC. Now for triangle ADC, we know the height is AE, so that means for this triangle, its side, which side? DC is the base and the height is AE. So that is what we wrote there. Now for the next triangle which we have, the bigger one, triangle ABC. For triangle ABC, height is AE. So we know what's the base? The base is nothing but BC. So we write the height and the base here. Now I want you to do certain observation from what we have got. Observe. Can you see something about the base or the height there? Yes, you will be observing one thing. That height AE, that's the same for all the 3 triangles. The heights are same. That means in such a situation, all the 3 triangles end up having the same height. They have equal heights. Why? There are 2 reasons to it. Now what is that reason? That is very important. That is very critical because that is what we write in the presentation now. The 2 reasons are very simple. All the 3 triangles here, they have a common vertex A. A is common for all the 3 triangles. It's there in triangle ABD, it's there in triangle ADC, and it's there in triangle ABC. So it has a common vertex. So that's the first thing which we write. Triangle ABD, triangle ADC, and triangle ABC have a common vertex A. The other thing is, from that vertex, we had dropped a perpendicular, right? Perpendicular on base BC. That base which we had, BD, for triangle ABD, the base BD, for triangle ADC, the base DC, and for the third triangle, the base BC, all the bases are on the same line. So we write there the bases BD, DC, and BC, they lie on the same line. And this is the reason, these are the 2 reasons which we are writing, because of which the triangles have equal heights. So that is what we write here. So remember what we learned here is, all the 3 triangles, they have equal height. There are 2 reasons to it. Because they have a common vertex and their bases lie on the same line. In such a situation, we can say that all the 3 triangles have equal heights. Now this is the most important one. Let's understand this in detail. Let's say I give you a triangle now. That's just an example for you to understand. Suppose I give you a triangle here. Observe here again. Isn't the situation the same like the one which we learned? Think. Yes, because you see out of the 4 points here, observe P, S and R. They are collinear. And the 4th one is not. So out of 4 points, whenever we have 3 collinear, you need to remember this situation. Yes, in this case, we have 3 triangles and all the 3 triangles will have equal height. We know the reason. The reason is because they have a common vertex. What's the common vertex? That 4th point which is outside. That's the common vertex, Q. And their bases, that is PS, SR and PR, lie on the same line. That's the reason. So we should be able to write the presentation that way. So we'll write here triangle PSQ, triangle RSQ and triangle PRQ have a common vertex Q and their bases. Now write the bases. PS, the bases PS, SR and PR lie on the same line, PR. Therefore, we know that their heights are equal. That's the way we present it. And once their heights are equal, we can use the property area upon area is equal to Base upon base. Now it's so easy. So suppose they ask us, what is area of triangle PQS upon area of triangle RQS? Now can we answer that? Yes, we know. For both the triangles, base, we know that heights are equal. So base upon base. So we write it is base upon base. That means it is PS upon SR, isn't it? Same ways, if I ask you the other set of triangle, that is triangle PSQ upon triangle PRQ, what is the answer? We know it is PS upon PR, base upon base. Now I give you the third set of triangle, that is triangle RSQ upon the bigger one, that is triangle PRQ. What do we get? We get it is nothing but SR upon PR. Wasn't that easy? This is the concept which we have learned. So whenever we see a situation like this, when I say situation like this, that's the trick I'm going to give you. Observe the trick. Remember, what we just observed is, whenever we have a situation like this, or when I say when we have a situation like this means what? Out of the 4 points which you see here, how many are collinear? Yes. So if 3 out of the 4 points are collinear, then remember that all the 3 triangles will have equal height, right? Heights of all 3 triangles are equal. And we know the reason. The reason is because they have a common vertex and their bases lie on the same line. That's what you need to remember. And after that, we can easily write area upon area, whatever they ask, because area upon area will be equal to base upon base. This is the concept which I want you to remember. Now, here, in such a situation, if they ask you a question like this, believe me, without seeing the figure, you can answer. You saw the figure, we came to know, yes, 3 out of the 4 points, 3 are collinear. That means we know the concept. They have equal height. And they ask you this question, area of triangle ABD upon area of triangle ADC. Now we know here, just look at this and tell me, what is the common vertex, that 4th point? Just remember, common vertex is A. So now, directly you can write base upon base without seeing the figure. If A is the common vertex, the bases are BD and DC. So it has to be BD upon DC. Oh, it is just BD upon DC which you write. Then, only in this situation, remember, here we know common vertex is A. So if A is the common vertex, then base upon base means what? It is going to be, yes, it is going to be BD upon BC, base upon base. So easy to write, right? Same way, if I give you the third set of triangle here, area of triangle ADC upon area of triangle ABC, because we know A is the common vertex, so just remove that, and whatever is left is nothing but base upon base. So we can write it as DC upon BC. Right? This is very, very important. So remember this situation. So we learned 3 situations. One, where the heights are given equal. The second one, when the triangles are lying between the same 2 parallel lines, the heights are equal. And the third one was this, whenever we have 4 points, out of those 4 points, if 3 are collinear, remember all the 3 triangles will have equal heights. But remember, that 4th point which is outside is a common vertex. And that's what we need to remember. That helps you to solve the sum very easy. Right? Very important concept.